Okay, solving two-step equations. After a couple of days of review of what you've been practicing, we finally get to have a little bit of fun with the math, or what I'll call fun with the math. You may disagree a little bit. I can live with that. What we mean by solving two-step equations is in our example 1, instead of just multiplying n by -8, we're also going to add 6 to it. And in example 2, instead of just dividing x by 6, we're also going to add 32. So we're not just doing one thing to x, or our variable, we're doing multiple things to it. We're doing two things to it. So the last couple of days have just been a lot of practice to help you get ready to solve these and make them a little bit easier. But you're going to have to slow down. You're going to have to work a little bit slower, pay a little bit more attention to what's going on in the problem so that you avoid making some common mistakes. And I'll do my best to help prepare you for a lot of those mistakes that the SAGE and other tests like to throw at you, including the one that I'm going to give you next week. So, step 1, before I actually start solving these equations, there's a couple of changes I want to make. Here on the left-hand side, for example 1, we have -8 times n plus 16 equals -24. I'm okay with the way that equation is set up. But in example 2, there's a few things I don't like. I don't like that my x is on the right-hand side. And so I want to fix that. I want to move everything on the right-hand side to the left. I also don't like that there's a negative in front of my x. And if you remember from the bell work, we can actually move that negative to be in front of the fraction, or I can move it to be on the bottom without changing the number. So I'm going to quickly rewrite this. Instead of -x over 6, I'm going to rewrite it as x divided by -6, and then I have to add 32, and that's equal to the left side, to 20. And now I like the way this equation looks a little bit better. I don't have a -x, and my x's are on the left-hand side. So, step 1, we're going to draw our railroad tracks on each side of the equal sign. So nothing's changed there. Step 1 with solving, we're going to still draw railroad tracks on the left and the right. And I'm going to do it to both of these equations. And step 2 says to blank if necessary. What we want to do is simplify if necessary. And what it means by simplify is we might need to distribute, like we've done with expressions. Remember, that's using the Santa hat method. Or we might need to combine like terms. Now, I put this step in here. None of the problems today are going to require you to simplify before you solve it. But starting next week, maybe even Friday, they are going to require you to do that. So I want that step in there so that you have it when you need it. And we also kind of skipped a step here. Something that I told you yesterday was really important. We're going to put a new step right here in between 2 and 3. We're going to call it step 2.5. And that step is to circle the variable and everything attached to it. So I want you to add that step in there. Circle the variable and everything attached to it. That means the number and sign. I told you that was going to be more important today than it was in the past, and here's why. It's going to help us decide what we need to do first when we're getting our variable by itself. So in example 1, we have -8 times n. Now what I have attached to the n is the -8, and so I'm going to circle -8n. And I'm going to leave the plus 16 alone. I only circle what's in front of the variable, not after it. Now in example 2, I have x divided by -6. So the -6 is attached to my x, it's being divided, and there's no sign out in front because we moved it to the bottom. So I'm going to circle that as well. Now if I move down to step 3, it says to undo all addition and subtraction first. we're going to undo all addition and subtraction first. And that's because we're working backwards. In the order of operations, we normally will multiply and divide first before we add and subtract, but we're working backwards. So we need to add and subtract first. And one thing that's going to help us to remember what to do with that is that circle around the variable. So I circled negative 8n. I can't change anything in the circle until everything on the outside is gone. So I can't get rid of the negative 8 until I get rid of my plus 16. And I can't get rid of this dividing by negative 6 until I get rid of plus 32. I have to undo all of those first. So in example 1, let's undo that. The inverse of adding 16 is subtracting 16. So I'm going to minus 16 from both sides. Now in my calculator, when I do negative 24 minus 16, that gives me negative 40. So on this side, I've got negative 40, and I still have my equal sign. The difference today is all we've done so far is get rid of the 16. So this part's canceled out, but I'm still left with negative 8 times n. So we require one more step. I want to undo this part next. We'll get to that in just a minute. Let's look at example 2. I've got x divided by negative 6 inside the circle, and I have a plus 32 on the outside. I've got to get rid of that plus 32. It's not attached to the x. So to undo adding 32, I'm going to subtract 32 from both sides. And on this side, it cancels out. And again, in my calculator, 20 minus 32 is negative 12. So on the right-hand side, I have negative 12 and an equal sign. And on the left-hand side, I still have my x divided by negative 6. I haven't gotten rid of that negative 6 yet. So that's step 3. We get rid of addition and subtraction, whatever's not in the circle first. So maybe off here to the right, we're going to put not in the circle. Now that everything on the outside of the circle is gone, we can move on to step 4. So that's to undo all division and multiplication. So we undo all division and multiplication next. One thing to remember when you're doing that is that we're changing the operation. We're not changing the sign. Meaning, in example 1, I need to undo multiplying by negative 8. Right now I've got n times negative 8, so I want to divide by negative 8. I don't want to change the negative, I just want to change multiply to divide. So on the right-hand side, I also need to divide by negative 8. So on my left, the negative 8's cancel, and all I'm left with is n, and that's equal to, on the right-hand side, I've got negative 40 divided by negative 8. So I do negative 40 divided by negative 8, and I get an answer of 5. I think my answer is 5. We're going to check that in a minute, but let's look at example 2. X divided by negative 6. The inverse of dividing by negative 6 is to multiply by negative 6. So I multiply both sides by negative 6, and they cancel out on the left. All I'm left with is an x is equal to. Now on the right, I have negative 12 times negative 6. I can do 12s in my head pretty good. 12 times 6 is 72, and a negative times a negative is a positive. So x should be equal to 72. That's what we think our answer is. All right, so when I look down here at step 5 and 6, it tells me that I need to solve for the variable, which we've done. We're not going to worry about leaving things improper because we're not dealing with rational numbers yet. We're not dealing with fractions. And step 6 is checking our solution. And this is another step that we need to be a little bit slower than we were with our one-step equations, because n is equal to 5. I have to plug that in. Instead of n, I want to put a 5 all the way up here in the original equation. And I have to be careful that I don't change it, that I write it the way it was written. So when I rewrite it, I have a negative 8 times n, but instead of n, I'm putting in 5. and then I'm adding 16, and I want that to equal negative 24. If it equals negative 24, I've done it correct. Now here's where we need to be careful. Now that we're solving this side, we're not trying to solve for x, we're trying to solve this expression. I have to follow the order of operations. So I do negative 8 times 5, and then I add 16. If you're confused about how to do that or which order to do it in, and you want to cheat a little bit, just plug it in your calculator. Negative 8 times 5, and then I'm going to add 16. Your calculator will usually do the order of operations correctly. And when I hit enter, I get negative 24, which is what I wanted. So this side is negative 24. This side is negative 24, which means that I did it correct. And my answer is n is equal to 5. Now we're going to do the same thing on this side. We're going to plug in, instead of an x, we're going to plug in 72. So on top I have 72 divided by negative 6 plus 32, and we want that to equal 20. We want that to equal 20 if we did it right. So, order of operations. I need to divide and then add, but I'm going to go ahead and put that in my calculator. I'm going to put 72 over negative 6 in my calculator, 72 on top, negative 6 on bottom, and then I'm adding 32, and I want to see what I get. So I get 20. So the left side is 20. That's equal to the right side, which is 20, which makes me feel good. We did our math correct. And we know we did it correct because we plugged it in and it told us it was the right answer. Okay? So that's solving two-step equations. We'll do a couple more examples here together, and then I'm going to have you try some on your own. You might need to slow things down. If you need to pause, rewind, listen to these things again, go for it. But I'm going to just jump right in, and we're going to move through these kind of quick. Step 1 is to draw our railroad tracks. And as you can tell, I wrote some new equations in here to get rid of our decimals and fractions. So go ahead, pause the video, write down those new equations, and then get back up here with me. So I draw my railroad tracks. Step 2 is to simplify. I don't have to distribute. There's no parentheses. I don't have any like terms on this side, so I don't have to worry about that. So I go to step 2.5, which is to circle the variable and everything attached. My variable is y, and it's attached to a 3. I don't care about the plus sign after it. I only care about the signs that are out in front of it. Okay, step 4, undo all addition and subtraction, whatever's not circled. So I need to undo this plus 8. So I'm going to minus 8 from the left. I'm going to minus 8 from the right. So on the left-hand side, those cancel. I'm left with 3y is equal to negative 19 minus 8. We'll put it in the calculator, make sure Mr. Reed can do math correct. Negative 19 minus 8 is negative 27. So on my right-hand side, I have negative 27. Now here's my second step. I still have 3 times y. I need to get rid of that 3. So I'm going to divide by 3 since it's being multiplied by 3. And if I do that to the left, I have to do it to the right. So those cancel. Negative 27 divided by 3. I think I can do that one in my head. 27 divided by 3 is 9. And a negative divided by a positive is a negative. So I think that my answer is going to be a negative 9. I think that y is equal to negative 9, but I'm not sure. I want to double check by plugging it back into my original equation. I'm going to run out of room here, so I'm going to move outside the box a little bit, but I have 3 times y, which was negative 9. So that's just from here to here. I'm just copying it down, but instead of y, I'm putting what I think y is, negative 9. 3 times negative 9 plus 8, that's supposed to equal negative 19. So let's plug it in our calculator. 3 times negative 9 plus 8 gives me negative 19, which is what I wanted. So this side's negative 19, this side's negative 19. I can check mark it, know that I got the answer correct. Okay, number 2. I've got my k on the left side, which I like, but I've got this negative sign kind of floating out in front. I don't like that. I want to get rid of it. I don't want it out in front. I want to get rid of it when I move things around. So I'm going to move that negative down here with my 9. So I'm going to rewrite my equation as k over negative 9 minus 1 equals 10. So I haven't changed anything. The numbers are still the same. I just put the sign somewhere else, which I can do when it looks like a fraction. Right? So step 1 is to circle. It's not to circle. I'm getting ahead of myself. Step 1, we're going to make our railroad tracks. We're going to simplify, but we don't have to. Now step 2.5 is to circle that k and everything attached to it. So that dividing by -9 is attached to the k. So I circled those things together. All right, I'm getting ahead of myself. Sorry about that. Number 3, undo all addition and subtraction. Everything that's not in the circle I need to get rid of first. So I need to move this -1 by adding 1 to the left and adding 1 to the right. So on the left, those are canceling, and I'm left with k over -9 equals, and on the right-hand side I have 10 plus 1. 10 plus 1, I hope we can all do that in our heads, that's 11. And now I have to get rid of my -9. Right now k is being divided by -9. To undo that, I have to multiply by -9. So I also have to multiply the right-hand side by -9. So these cancel. I'm left with k equal to 11 times 9. 11s are pretty easy for me, so I can just tell that that's 99. And then a negative times a positive is a negative. So I think that my answer is going to be -99. But I'm going to quickly plug that back in and make sure. Okay, so all the way up here at the top, I have a negative k divided by 9. So I have a negative, and instead of k, I'm going to put -99. And that's going on top of 9. And then I'm going to subtract 1, and I want that to equal 10. So I'm going to put this in my calculator. I'm going to be a little bit careful because I have some funny things going on. I have a negative out in front, and then I have a fraction. And on top of my fraction, I have -99. On the bottom of my fraction, I have 9, and then I need to minus 1. So my equation right here looks like the equation on the paper. So I feel like I put it in correctly. When I hit enter, I get the answer of 10, which means the left side is 10, the right side is 10, and I did the math correct. Okay? I know that's a lot of steps compared to what we've done in the past. I'm okay with that. That's what real-world math looks like a lot more often than just multiplying one thing. So we're going to slow down. We're going to follow the steps. We're going to check our work. We're going to take our time and make sure that we do these problems correctly. So rewrite problems 1 and 2 on your pause and try. I want you to solve those problems and then bring them up to me at the table. As long as everything looks good, we'll get you moving on and practicing with the homework.